In this class, we're going to go over questions on velocity time graph. Okay, let's start with the first question. We are asked to consider the diagram on the board. The diagram on the board represents the velocity time graph of a body in motion. The total distance traveled by the body is 195 meters. Calculate the acceleration of the body in the section OP. You understand? Now look at the question. Please kindly pay attention. If you look at this velocity time graph, we will discover that the first motion of the object is acceleration. Why? Because the body accelerates from this point to this point. You understand? Then it maintains a constant velocity at this point, from this point to this point, then decelerates. You understand? Okay. Now, please kindly pay attention. We are given the question that the area is 195 meters. You understand? So let's start with that. The distance, the total distance traveled by the body is equals to 195 meters. Don't forget the goals. The goals is to determine the acceleration from point O to point P. You understand? That is what we want to find. But we cannot know the acceleration without calculating the velocity. You understand? Because acceleration tells us how fast the velocity of an object is changing. Okay, so in an attempt to help us to determine the acceleration, we first need the velocity. You understand? We need the maximum velocity. Now, I told you in our previous class that when you talk about distance on a velocity time graph, the distance represents the areas of the shape that the velocity time graph gives. You understand? Now, if I ask you this question, what is the shape of this? What is the name of this shape? Let me draw the diagram out. What is the name of this shape? Because this is how the velocity time graph look like. This OP, then we have Q. Let me call this one S. You understand? Let me put S here. Point S. Now, what is the name of this shape? Of course, this shape is a trapezium shape. You understand? So now, this place that you see here, the point that you see here is known as the height. You understand? Now, with respect to the formula for calculating trapezium, you understand, the areas of a trapezium is given by this formula. 1/2 multiplied by A plus B H. You understand? 1/2 multiplied by A plus B multiplied by H. A is the two parallel sides of the trapezium. You understand? Trapezium has two parallel sides. The first parallel side is PQ and the second parallel side is OS. You understand? So, now, in that case, since we know that the area is the total distance traveled when we talk about velocity time graph, you understand? Note that the area of velocity time graph gives the total distance traveled. So the reason why I want to make use of this area, the total distance, is because I need the height. You understand? Because height in velocity time graphs tells us the velocity. Okay, you know, velocity is on the vertical axis. Okay, velocity is on the vertical axis. So now, if I know the height, I can easily determine the velocity I can easily determine the velocity at this point. You understand? And because the velocity at this point, if I know it, I can easily determine the acceleration from this point to this point. Okay, so let's proceed now. So let's get the height. Please kindly pay attention. Let's get the height. Now, we've been given that the area, we know that from the formula of a trapezium, area is equals to 1/2 multiplied by A plus B multiplied by H, where A and B are the two parallel sides of the trapezium. Don't forget, parallel sides are those sides they can never meet. You understand? So here, I'm gonna put something like this. A is also the same thing as the distance. So I'm going to have 195 meters is equals to 1/2. Okay, just put it A plus B. Now, please pay attention. The distance from this point to this point will be the difference between this and this. Okay? This side and this side, they are the same. Why? Because this side and this side, this side and this side, this side and this side, they are the same. The reason is because it looks like a rectangle. You understand? If you draw the shape, this PQ, you understand, it looks like a rectangle. You understand? So in that case, if I want to get the length of this side, that is what 11 minus 6. Do you understand? And 11 minus 6 will give me 5. You understand? So the length of this side is 5. Okay, this is 5. And if this side is 5, that means that this side is also be 5. You understand? Because a rectangle has two opposite sides are equal. You understand? In a rectangle, the two opposite sides of a rectangle, they are equal. So this side is equal to this, and as well, this side is equal to this. But we are mainly concerned about this side. So this side is equal to this side. Hence, that means that this is A and this is B. Okay? So according to this formula, A will be B will be 5. You understand? B will be equals to 5 meter. How do I know? Because the difference between 11 and 6 is 5. So this the length here will be 5 meter. The length here will be 5 meter, and this length here will also be 5 meter. And I told you that A and B are the two parallel sides of the trapezium. So if this one is 5 meter, this will also be 5 meter, and this is B. You understand? That means that B is 5 meter. So what is A? A is the other side that is parallel to B. Now, that means that A is from this point to this point. Please pay attention. What is the total length from this point to this point? That is what, 21. Okay, so that means that A will be 21. Okay, just put 5 and 21. Now let's calculate. Area, which is 195 meter, is equals to A plus B. That is 5. 21 plus 5 multiplied by h all over 2. You understand? You see, this formula can be written as A plus B multiplied by h divided by 2. If you multiply half by this, you are still going to have this. Okay, so let us proceed. So for this, I'm going to have 195 is equals to, you can put meter and you can decide not to. So 21 plus 5 is 26 multiplied by height all over 2. So I'm going to have 195 is equals to 13 multiplied by height. See, 26 divided by 2 will give us 13. Don't forget, the goal is to determine the h. You understand? The goal is to determine the height. So in that case, I'm going to divide both sides. I'm going to divide both sides by 13. Okay? So here, this divided by 13 and this divided by 13. So height is equals to 195 divided by 13 will give us 15. Now, because in velocity time graph, the height symbolizes the velocity. You understand? So in that case, I'm going to have V is equals to 15 meter per second. Okay, so the velocity at this point is 15 meter per second. So having gotten the velocity, we can easily determine the acceleration from this point O to point P. How do we do that? Don't forget that acceleration tells us how fast the velocity of an object is changing. Acceleration is equals to change in velocity all over time. So I'm going to have A is equals to change in velocity. Now, please pay attention. I want to take some things out. This is point 0. I'm very sure you understand. Now, the initial velocity at this point is 0 because the object is not moving. You understand? That means that the velocity is 0. Now, this is the final velocity, which is 15 meters per second. And now, the time at this point is 0. Why? Because the object is not yet in motion. And the time at this point is what? Is 6. So, in that case, the acceleration is equals to V minus U all over T2 minus T1. Acceleration is equals to V, which is the final velocity, 15 meters per second. 15 minus 0 all over T2. T2, see, let me tell you, this T2 is the final time, you understand, in seconds, and T1 is the initial time. The initial time is 0. Why? Because the object is not in motion, okay? So, in that case, I'm going to have 6 minus 0 as well, 6 minus 0. So, the acceleration is equals to 15 divided by 6. Acceleration is equals to 2.5 meter per second squared, okay? So, that is the solution to that question. If you have any question, let me know in the comment section. Okay? See, in solving velocity time graph question, you have to pay attention to the details of the question. I start by writing out the parameters that are given in the question. The distance is 195 meters. The acceleration that we have to calculate is acceleration from this point to this point. But I cannot know the acceleration without knowing the velocity at that point. Because when an object accelerates, it attains a velocity. that velocity, I need to know it before I can determine the acceleration of that object. So when the object accelerates from this point to this point, I knew that it accelerates. That velocity that it reached is known as 50 meters per second squared, and that is what I first determined by taking into consideration the distance that were given in the question. And we know from our previous class that when we talk about the area, the distance on the velocity time graph, the areas of the shape give us the distance, you understand? And I knew that this shape is a trapezium shape, and the formula for areas of the trapezium is 1/2 multiplied by a plus b multiplied 1/2 multiplied by a plus b times h, which can be written as a plus b h all over 2. Okay, and a and b are the two parallel sides. You understand what I'm trying to say? So in an attempt to help me solve this, I draft out this diagram. A is one of the parallel side and B is one of the parallel side. Now I know that this side and this side and this side and this side, they are equal. Why? Because the shape is a rectangular shape, and in a rectangle the two opposite sides are equal. Are you getting what I'm trying to say? So since the two opposite sides are equal, that means if this one is 5, how do I get 5? I take the difference between 11 and 6 to get this line. You understand? And if this one is 5 meter, this will also be 5 meter. Having done that, I knew that B is equals to 5. Now, how do I got my A? A is the total length from this point to this point, you understand? That is from this point to this point. And we've been given as 21. Please listen, we've been given as 21 because from this point to this point is 6. From this point to this point, is 5. 5 plus 6 is what? 11. From this point to this point, will be 21 minus 11. That will be 21 minus 11 is 10, and if you add 10 to 11, you're going to have 21. And if you can't do it like that, you can just proceed like this. From this point to this point is 21. You understand? So that's how I got my A as 21, which is the length from this point to this point. So I proceed to substitute both A and B into this equation and then get the H. And in velocity time graph, H is the velocity. You understand? So I said V is equals to 15 meters per second. You understand? Because velocity is measured along the vertical axis. So, and when we talk about height, we are talking about velocity. Velocity in velocity time graph. Okay, so height signifies the velocity. Having gotten height as 15, that means that the velocity that it reaches when it accelerates is 15 meters per second. You understand? So, having done that, I just plug in. I use the formula for the acceleration, which is v minus u all over t2 minus t1. And then I knew that because the object is not accelerating from this point, there is no change in motion, it's at rest. That means that the velocity and the time, the initial velocity will be 0 and the time will also be 0. Okay, so, and I know that when it accelerates, this is the velocity that it reached. Having gotten that velocity, I calculate v minus u, which is the final velocity minus the initial velocity. 15 minus 0, 6 minus 0. How do I get the final time? Because you see, let me tell you, if you are told to calculate the acceleration for the total journey, we'll have considered maybe this time, but the acceleration that we have to calculate is from this point to this point, from this point to this point. You understand? That means that the time that we're going to consider will be from this time to this time. And this is the final time, which is 6. So I substitute 15 divided by 6 is 2.5 meters per second squared. Okay, so that is the solution to that question. If you have any question, let me know in the comment section. See you in the next class.